Hi everyone, Dr. Block here, looking to go over with you now how to draw the Lewis structure and the structural formula for covalent compounds, that is compounds that have covalent bonds, and identify the number of bonds and pairs of shared electrons between the atoms of covalent compounds. But first, let's go over a few things. Covalent compounds are also called molecules. Every time you hear covalent compound, think molecules and vice versa. The bonds form between two non-metal atoms. So that's in the upper right hand corner of your periodic table minus group 18, which are your noble gases. Now, because all nonmetals have high electronegativity values, they share their valence electrons in order to stabilize their individual valence shells. Now, what that means is, well, electronegativity relates to the affinity for acquiring new electrons. Both atoms want new electrons, so neither one can get them, so they share them. Furthermore, every pair of shared electrons equals one bond. So if you're sharing two electrons, that's a pair, that's a single bond. If you share 4 electrons, that's 2 pairs, a double bond. Share 6 electrons, that's 3 pair, a triple bond. Now, in contrast, the bonds of ionic compounds transfer electrons from one ion to another. Now, here are some general guidelines. Write the individual atoms as Lewis dot structures. Try to piece the atoms together so that all of the atoms have their valence shell full and stable. You might have to manipulate the placement of the electrons. And lastly, and most important, trial and error is the key. Do not be afraid to make mistakes. Now let's go ahead and try some of these. Now at any time that you feel as though you have some confidence, go ahead and pause it. Try them on your own and compare your answers. Looking on the bottom right of this page, you will notice a periodic table, or portion of, with groups 13, 14, 15, 16, 17, 18 is omitted, although it's full of nonmetals. They're noble gases, they are non-reactive. And here we have a nonmetal that is listed on the side of the periodic table with the metals, known as hydrogen. So it's there for us to review. Got 4 compounds, actually 3 compounds and 1 elemental fluorine. We have hydrogen chloride, hydrogen bromide, water, elemental fluoride, fluorine I should say. Individually, here is a hydrogen, building the first one that is. 1 dot, why 1 dot? 1 valence electron. So looking at chlorine, how many valence electrons? We have 8. So let's go ahead and take a chlorine and see what happens when we put them together. There we go. Now the test to see if you've done it correctly is simply this. Draw a circle around the element and all the dots that immediately surround it. We have 8 dots surrounding this chlorine. The chlorine's valence is full and it's good. The hydrogen has 2. The nice thing about this is hydrogen is only filling up its first shell, and that's our only break to the octet rule, where we could have 2 electrons filling that shell to stabilize it. This element is written correctly. Now take a look right in between. You will notice that there are 2 electrons being shared between these. The hydrogen and the chlorine are both using these electrons to stabilize their outer shell. So it's sharing 2 electrons, it is sharing 1 pair of electrons, and that is equivalent to 1 bond. Need to clean up the screen now. And we are going to attempt another. We'll try the hydrogen bromide. The hydrogen bromide. Grab a hydrogen. Grab a bromine atom. Let's make this a little bit smaller so scale is correct. And draw our circles. 8 electrons encircling the bromine atom and 2 around the hydrogen. How many electrons are being shared? 2. 1 pair. This is a single bond. Let's now take a look at water. Take this off our screen. Alright, now we're going to need 2 hydrogens. There's one. Here's another one. And we're going to need an oxygen. Oxygen has 6 valence electrons, as denoted right here. Now, how do these fit together? Let's slide this hydrogen here. In reality, we'd probably write it a little bit higher. And this hydrogen, we can twist it and place it right here. Not the cleanest way, but it works. This hydrogen has 2 electrons. This one, 2 electrons. The oxygen, 8. Now let me rewrite it just so you would see what it might look like. That's without all the twisting, just so you know. Alright, now there are 2 bonds here, 2 single bonds, one between this hydrogen and oxygen right here, and this one right here. Now let's do the elemental fluorine. I don't need to clean the screen completely, just enough space for that. Alright, let me take one fluorine and another one. Draw our circles around it. That fluorine is happy. That fluorine is happy. Now please remember, this is not a compound. This is an element. 2 atoms of the same element are an element. Okay, now let's try these two. This first one is called carbon tetrachloride. And what we will do is we'll bring a carbon into play here, and I will free draw the chlorines. It will present much better that way. Okay, there's the carbon, 4 valence electrons, identified by 4 right there. Chlorine, each of them has 7 valence electrons. Let's draw them. Here's 1 chlorine, 2 chlorines, 3, and 4. How many dots each? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Let's go ahead and see if, in fact, everyone's happy. That chlorine, happy. That chlorine, 8 valence electrons, happy. This chlorine and this chlorine. All of the chlorines are happy. What about the carbon? It's ecstatic. They each have 8 valence electrons. Take a closer look right here, and you will notice that this chlorine and that carbon are sharing 2 electrons. That's 1 pair equaling 1 bond. We can also write that in this way. Let me get this off of the screen. Clean this up. We could write the structural formula. It looks like this. Just have to get some new pens. There we go. We've got our carbon. Sorry, that's a chlorine. A chlorine. Put the carbon in the center. Our chlorine. Chlorine. Now, each pair of shared electrons can be represented by a dash. And that's the structural formula. Now, NH3 on the other hand, it looks like this. I will freehand in the hydrogens. 1, 2, 3. 1, 2, 3 dots. Is this happy all around? That hydrogen is happy. Let me make that line a little thinner. There we go. That hydrogen is happy. That hydrogen is happy. That hydrogen is happy. But what about the nitrogen? It too has 8 valence electrons. It's happy. What would its structural formula look like? Let me clear a little space here. And draw it for you. This one looks like this. Nitrogen with a hydrogen, shared pair of electrons. Here's another shared pair of electrons to a hydrogen. And, well, that would be it, but we could also put in the 2 valence electrons that are free on the top end of the nitrogen. Okay, these two are going to be a little bit trickier. I'd like you now to pause this video and try them yourself. Remember, the key to this is trial and error. Alright, so let me build it for you. Oxygen has 6 valence electrons as noted right here. So let's put in those 6 dots. 1, 2, 3, 4, 5, 6. And let's build another oxygen right next to it with another 6 dots. 1, 2, 3, 4, 5, 6. The dots aren't as pretty anymore. Trying to work a little faster now. Now, take a look at this. It's happy. 8 dots surrounding that oxygen. 8 dots surrounding this oxygen. But what makes it different? How many electrons are being shared? A total of 4. 2 pairs. Remember, every pair equals a bond. This has a double bond. Structural formula could be written like this, or it could be written with the other valence electrons noted like this. Now, carbon dioxide. Let me build this one for you, but please pause, try it yourself. Alright, here's what it looks like. Carbon. Actually, I slipped up just a little bit. Carbon, and there are the 4 valence electrons, and oxygen. Let's test this with our circles. That's happy, happy, happy. If you need to, pause the video and look for yourself. How many electrons are being shared right here? 4. That's a double bond, as is right here. The structural formula can be written as, and the extra valence electrons can also be identified. Not always, though. Well, now that I've shown you single bonds and double bonds, guess what's next? Well, pause, try this one yourself. Well, here's where it goes. Nitrogen, 1, 2, 3, 4, 5 valence electrons. Another nitrogen, 1, 2, 3, 4, 5 valence electrons. Go ahead and do the circle test. There's 8 surrounding that nitrogen, 8 surrounding that one. How many electrons are being shared? 6 total, 3 pairs. That's a triple bond. Can be written as, and the extra valence electrons can be placed in also. Thank you very much, everyone.